4, Fibonacci numbers. This is a new topic, but this is a very big topic. So I want to start the first video on this topic in the end of part B. Yeah. In the next part, we need to spend a lot of time to study this topic. Yeah. So let's start with the problem first. Our problem 11, calculate Fibonacci numbers. First, we define the Fibonacci numbers using recursion formula. Yeah. And we can calculate the first few Fibonacci numbers using this formula. It looks pretty easy, right? Yeah, the calculation, straightforward. But, so there are many interesting properties related to Fibonacci numbers. All right. To solve this problem, we use this plan. Still, two different directions. The first one, solve it algorithmically. So we need to use some algorithm to solve it. Yeah. So write a computer program to implement some algorithm. Good one or bad one. Yeah. Second method, solve it mathematically. Derive a math formula. If we have a math formula, then we do not need any algorithm, right? We just apply math formula to find the Fibonacci number directly. All right. So let's do based on this plan. First, when we start, we want to use the easiest way. So not necessarily the fastest way. Usually the easiest way is not very good. Yeah. Because we have the recurrence relation, we just put it in a recursive function, yeah, like this one. So you can see, pretty easy, right? Yeah, pretty easy. Two base cases. Other than that, recursive function call. That's it. Okay, yeah. So this is our first solution. Yeah. After that, we want to know, is this a good solution? How good or how bad it is. We want to know that. Yeah. First, it solves the problem correctly. It gives us the correct answer. No problem. Yeah. But the question, is it good implementation? Are we satisfied with this solution? The answer is not. Answer, later you will see, really bad solution. Super bad. Yeah. So why? Super bad. Yeah. You will see the result, how bad it is. Yeah. All right. And this one, yeah, because this problem, it's a pretty good project, so we can work on. So the project plan, compare efficiency for two different algorithms calculating Fibonacci numbers. A bad one, very slow one, and a good one, very fast one. In this way, you can compare how much is the difference between a really bad one, a really good one. Yeah. So in this way, you can get the importance of a good algorithm. Yeah. All right. But before we do that, we want to know how bad is the algorithm. Can we improve it? Yeah. So first, I want to explain why our current solution is really bad. Here, I like to use a simple diagram to explain the reason it is bad. So let us draw a recursion tree. So when we implement, actually, our calculations corresponds to this recursion tree. Here, I just start with a fiber of 6, a small value, because I cannot draw a tree very big. So this n equals 6 is already good enough to show us the whole picture. In order to find fiber of 6, you need to get a fiber of 4 and a fiber of 5. Then recursion, right? Yeah. So we go down in our tree level by level. So you can see all the levels like that. Then, because we have the values at the bottom level, fiber of 0, fiber of 1, so then we can move up to do the calculation and get a final answer. Yeah. But can you observe some special property in this tree? Some property. The most prominent property in this tree. Can you see that? Yeah. Here, the observation. If you look at a fiber of 2, can you see how many times this node or this number appears in the tree? Yeah, that's important. This number appears in the tree. See? Many times. In this small example, 5 times. Then you can imagine if we have a general fiber of n, a big tree, then many nodes or many fiber values. Yeah, here I do not want to say node. Yeah, fiber values will appear large number of times. That means we need to do a lot of redundant calculation. Redundant calculation, you do not need that many calculations. Yeah, that means you waste a lot of computation time on unnecessary calculation. So that's the reason it is very, very slow. Yeah. In the project, you will see it is extremely slow. Okay, yeah, yeah. I try to, give you a complete description of the project, yeah, related to this topic. So let you feel about it. Yeah. All right. Now we know this solution is not good. Yeah. So next question: how to improve it? We want to have some efficient algorithm solving this problem. Yeah. All right, so here, before we find a better solution, so we want to see in our current solution, what is the main issue. Yeah. So which part we can improve. Yeah. Here in this iterative method, you can see this recursion part contains too much redundant calculation. Yeah. So that part yeah, so that part we need to improve. So our method 2, we take these steps for the improvement. So the recursive algorithm without redundant. Yeah. So that's the main thing we want to do. How can we avoid redundant computation? The method, very simple. Use an array to store calculated values. If you already calculate some Fibonacci numbers, you should not calculate it another time. In other words, each Fibonacci number should only be calculated exactly once. No more than once. That's important. If you can do that, then you avoid redundant calculation. Here, how can we do that? We use an array to store old calculated values. So that's the main idea. Make sure that no value is calculated more than once. How do you make sure? That's easy. If you see the value already stored in that array, then you do not need to do the calculation. You just return the value from that array. So now let's do the implementation. Fibo of n, we store it in an array called f of n. That array. Okay? The code is like this. All right, so the code is like this. Okay? We create an array we call a known f array. Known f. Why we call it known f? The known value, before the calculation, you do not know those values. After the calculation, the known f array stores the known values. So that's important. Okay? All right. So you can initialize the known array, initialization, initially 0, right? All elements 0. You do initialization. Then, during the calculation, whenever you find one Fibonacci number value, you change the value in that element. So it will be greater than 0. So here you check. If it's greater than 0, you just return the value. No new calculation. Otherwise, you do the calculation, recursive function call. You can still do the recursive function call, but this method guarantees each Fibonacci number calculation only once, no more than once. So you can see this simple treatment can help us avoid redundant computation. This method, pretty simple, but the idea is big. So the idea is a big idea. How big is this idea? It is called a dynamic programming idea. So that's the topic of our chapter 8, dynamic programming. That's the idea. Very important idea. For this class, we may not have a chance, although I tried to, but based on our realistic situation, we may not be able to cover that topic. Even if I like this topic a lot, but still a little hard. But here we get our first view of this topic, dynamic programming. All right. It main idea of this method, no repeated calculation. If you can avoid repeated calculation, you implement this dynamic programming idea and your algorithm will be much more efficient. All right, so here that is the introduction part. introduction to the Fibonacci number problem, but also introduction to dynamic programming technique. Yeah. All right, so let me stop here. Yeah.